Let's think about where we are at our finding derivatives journey. Recall that the derivative is always going to be based on the slope. We've got the definition of the derivative that's always going to be based on the slope, but that is very cumbersome. To have the conversations that we need to have, we need shortcuts to differentiation. We need to be able to find derivatives quickly and easily. So to that end, we learned a bunch of basic derivatives. The derivative of a power. This includes fraction and negative exponents. The derivative of exponential functions, that's where the exponent is the variable and the base is constant. So just kind of switching those two around. And then we learned our first four trigonometric function derivatives. Then we had to learn the three rules for how we combine those derivatives. The chain rule, that's for compositions. The product rule for products, and the quotient rule for quotients. Those are the three ways that we can combine our basic derivatives that produce derivatives. Well, we need rules that are more complicated because they're more complicated because sentence is difficult today, apparently. Those are the rules, compositions, products, and quotients, where we can't just apply the derivative in the same fashion. Like when we had adding and subtracting, the differentiation is a linear transformation. So we can just differentiate a term at a time. But when we have compositions, products, and quotients, then we have to have the special rules. This is how we want to organize things when we think about what we're doing. The basic derivatives, this is a memory check. We just have to remember these. This is like your times tables. Back in the day, you had to remember your times tables. I don't know if you had to memorize your times tables, or you just had to work out with the times tables enough that you remember what they are. If you had to memorize them, that's unfortunate, but that's what you had to do. Or you just remember them because you just did this over and over again, and you can't forget them now. So your basic derivatives, this is a memory check. These are just things that you have to remember. And when you're applying the rules, it starts off, you have to remember the rules. So step one, you have to remember what the rules are. But step two, this becomes a reading exercise. Over in this column, when we're going to apply a chain rule, a product rule, or a quotient rule, this is a reading exercise. So this is where we are a reading exercise. It's memory first, but then it becomes a reading exercise. We have to be able to look at how a function is put together and read what that function is telling us to do. Are we multiplying functions? Are we composing functions? Are we dividing functions? If we're adding functions, then life is easy. We just separate by term. But when we're multiplying, dividing, or doing compositions, that's when we need special rules. So that's why the problems in section 3.5, when we get to trigonometric functions, look so weird when you're doing the homework. So the natural question would be like, oh, what is the purpose of all these functions? And the purpose of all these functions in section 3.5, at this point, we have the chain rule and the product and quotient rules, exponential functions, powers, polynomials, and trigonometric functions. We're here when we get to 3.5. The purpose of all those things is to increase your ability to read those things. After you get out of this class, you don't have to really read those things anymore. It's not like if you're going to be in your job working on our mission to Mars, and your boss comes in and says, we need you to calculate these derivatives. And you're like, oh, got it, boss. And then you start busting out your product rule, quotient rule, chain rule. Your boss will be like, oh, what are you doing? You're like, well, I'm about to use derivative, just like Leach taught me. That means you're about to get fired. If you're about to use the product rule, quotient rule, chain rule in your calculations, you're probably about to get fired. That wasn't doing that later on, not the point. In a math class, almost never the point. Does that make sense? We really need to understand that it's not about doing this now because you're going to be doing it later. That's not how anything has worked ever, unless you are doing an apprenticeship, which this is definitely not. Does that make sense? I don't know if any of you ever go to the gym, but there's an exercise at the gym called a lateral raise. It's when you grab something heavy and you lift it out to the side like this. No one ever looks at their trainer and says, dude, why am I picking it up like this? No one ever picks anything up like this. If I want to pick it up, I'm going to pull it towards me and use my legs to lift because I don't want to hurt my back. Nope. They just like do this and you're like, oh, okay. And yet when I'm like, all train, you're like, oh, I don't know how to do this. Why do I do this? You know what I mean? I've seen this one. It's not about getting that's the answer. Part of this is about reading the way we write things. That's the thing that we need. Math is a very precise written language. We have to be able to decipher what we're looking at. All right. To that end, I have built some stupid functions. So that's like just like the way we do things. So let's look at some stupid functions. So I'm going to start with, I'm not going to pull all three of them down. We're going to do them in turn, but I'm going to write all three of these down. So let's say f of x is going to be e to the 3x times sine of 2x. See, I just gave it away. G of x is going to be sine of 2e to the 3x. And h of x is e to the 3 sine of 2x. Pause for copying. Until most people aren't looking so I can scroll. I can tell that we do not like this. This is one of the things that's happening. If I had just spoken a sentence that went from one side of the page to the other, if I just spoke a sentence and I enunciated better than I normally do, if I had just spoken a sentence and I said, write this sentence down, you would have heard me write it down, see that I'm starting to write it down, and just written it down. Think about how many times you had to look up because of the three functions that I wrote. I used all the same elements in all three functions. And to write these three things down, you were like, oh, fucking, wait, what is that one? Dick move on my part. But it illustrates the point that we're not working with, we can't work with our natural language skills. Those skills are not really going to be in play here in math class. This is a reading exercise, and we have to read slowly and carefully. We can't be hooked on phonics. We can't be guessing at what's being written. We have to write down precisely what's being written, even when I mess it up. The reason that this is difficult is that I'm asking you to be more like a machine, more like a computer, and look at exactly what's there. And I'm not trying to be disrespectful, although it is a little bit disrespectful when you try to treat your brain like it's a machine, like a computer. It is so much better than that. It is so much better than a computer. Computers wish they could do the shit that our brains do. Some say they will eventually do that, not until they get way more powerful than they are now. Look at what they're going to have to do for a fraction of our power. All right, so we've got these three functions. They all have the same elements, an e to the 3x and a sine of 2x, combined in some weirdo ways. I didn't use a quotient because that one sticks out. We have to decide whether it's product rule or quotient rule. So this is a reading exercise. We have to decide how these functions are being combined. First of all, do we all see an e to the 3x and a sine of 2x in various combinations? Sometimes I just stick the two together with multiplication, and sometimes I took one and plugged it into the other. That's the first thing that we have to decide. in the first one, in f of x, the thing that stands out is there's an e to the 3x and there's a sine of 2x. There's like these two instances of x, and they're just written next to each other. So that's kind of telling you product rule. I know a lot of you looked at this first one and said, dude, that is obviously product rule. Stop talking about the product rule. But we have to think about why we know that this is the product rule when we come across something that is less familiar. One of the things that we notice here is the two instances of x. That kind of indicates to us that this is a product rule. So just our reading exercise here, I'm reading this as a product rule. Now, one of the things that tells us product rule is that there's two instances of x, so that there are two functions of x. We want to clearly see two functions of x. We want to see those two functions of x. That's the reading exercise that we see here. You may have looked at this and automatically decided that, but we can't be running on autopilot. We need to build experience. We need to understand why our brains are reading things the way that they're reading. In g of x and h of x, these stand out to me as having those two different operations, the e to the 3x and the sine of 2x, but in each of these, we only see x appear one time. So the x only appears one time. We definitely see multiple functions going on, but we only see x one time. In each of these functions, we only see one instance of x. So we can't have a function of x multiplied by another function of x. We're not multiplying here. We must be composing the function. That tells us chain rule. Any questions? With product rule, we just have to identify a first function and a second function, and it doesn't matter which one is which. With the chain rule, the order does matter. We have to identify what's the inside function, what's the outside function. So we have to remember we're doing different things. Another thing to note is that just sine by itself without an x does not mean anything. Sine by itself without an argument is not a full thought. So note. Sine of x, that's a thing that we can work with. Sine is not something that we can just, there it is, it's just sine. Sine of what? Sine of what? There has to be an of what. That would be like, if I just wrote sine, if you just write sine, that would be like saying, find the answer, 5 plus. That's what you're saying when you just write sine by itself. That is just the equivalent of saying 5 plus, and then everybody's left hanging, right? 5 plus x, I said that for those of you who are like, oh, you can't just leave us hanging like that. Some of you like brushed it off immediately. Some of you are like, oh, 5 plus what, motherfucker? Come on, come on, come on. So I'm like, 5 plus x. That's a complete thought. That's saying to do something. That's saying sine of x. Just saying sine is the equivalent of saying sine 5 plus. There's nothing there. But if you say sine of x, that's a thing. That's why we don't want to see this sign here and think that is being multiplied by 2e to the 3x. Because it's not sine of x, times 2e to the 3x. It's sine of that stuff. Any questions? How's everybody okay? So in this problem, the first in f of x, it's all one problem. In f of x, we want to identify a first function and a second function, and then take the derivative. So our first, it can be either one. So let's just make the first e to the 3x. The derivative of the first is 3e to the 3x. We have to use the chain rule because the derivative of e to the 3x is e to the 3x times the derivative of 3x, which is 3. So here we are using the chain rule. Our second function will be sine of 2x, and the derivative of the sine of 2x is cosine of 2x times 2. I want to start building the habit of, instead of writing the derivative of the inside just at the end, identifying when it's a constant and writing it first. We want our constant coefficients to be listed first. This is weird for Americans because we put the dollar sign in the stupid place. But it's very American. It's like, I'll say the dollar part first. Write the dollar symbol first. Now we're ready to put together the product rule. We saw this is a product. We identified a first and a second, found the derivative of the first and the derivative of the second. So f prime is the derivative of the first times the second plus the first times the derivative of the second. This is just putting things together into the product rule. This we don't like because that 2, the constant 2, the coefficient 2 is in the middle of our term. We don't like coefficients to be in the middle of our term. So we might want to, if we didn't see it coming the first time, then we have to rewrite the whole thing. Some of you are like, oh, nah, man, I got an eraser. We want to get in the habit of writing our constant coefficients as the first thing in a term. Partially, this is aesthetic, and the other part is I want to see that you can identify where the terms start and end. Did you read the problem correctly? Notice that both of these terms have an e to the 3x as a factor. A lot of times what you see when you go, say, to check your answer on some resource like Wolfram Alpha will look for will look for common factors like an e to the 3x and pull the e to the 3x out. So you might see this written as e to the 3x times 3 sine 2x plus 2 cosine of 2x. Sometimes you'll see, especially when computers are doing things, you'll see a common factor getting factored out. When you start using Wolfram Alpha, just to type what Wolfram Alpha tells you, I want you to know it's not obvious in every situation, but there are certain instances where it is super obvious that you're doing that. I can always tell when you just copied things from Wolfram Alpha because the function will be formatted in a way that no human would format it, because it's being formatted by a machine. Eventually, Wolfram Alpha will be teaching this whole class, and it'll be telling that you have to format it in this weird way. Get your test back, Wolfram Alpha will be improper formatting. I have 80s computer voice, so I can't do like the uncanny valley AI voice that they put on all the videos now. I'll have to work on that. Now I'm thinking about how I would practice sounding like the AI that they put over on for the voiceover. Anyway. Stop. All right, there we go. Back. So in the other two, we have a composition of functions. Remember, this is a reading exercise. Did we have two instances of X? If not, it's probably a composition. We have to think about what goes first. What's the inside function? This is why instead of saying first and second in the chain rule, I was saying inside, outside, because I was going to be saying first and second when I got to product rule. So in the sine of 2e to the 3x, 2e to the 3x is our inside. And our outside function is sine of stuff. I put the parentheses there because I need something after the sign. I don't want to say 5 plus and leave it at that. But I'm just going to say 5 plus some stuff. When we read inside, outside, and we say that the outside is sine of stuff, that's when we pull our memory. We go into our memory banks. Remember that the derivative of sine of something is cosine of that thing. The derivative of sine of stuff is cosine of that stuff. So for G prime, the derivative of sine of some stuff is cosine of that stuff. Here we are in the memory bank. Times the derivative of that stuff. The stuff that's inside is a 2e to the 3x. And then we have to multiply by the derivative of the inside, which is going to be 2e to the 3x times another 3 for the chain rule. So that first 2e to the 3x is the first derivative of the inside, but we'll also have the 3x is also another derivative of the inside. So there's more derivative of the inside. This showed up yesterday on the problems, because instead of just doing 2 sine cubed of x, I did 2 sine cubed of 5x. And that means we had to do the derivative of the sine, which is cosine of 5x, times the derivative of 5x, which is 5. So that's why we ended up with 30s in those first 3 problems. This is messy how we would write this. We have coefficients. This is all just one term, and there's constants everywhere. So we would definitely want to clean this up. So 2 times 3 is going to be 6. I like my exponentials to go for my trigonometric functions. Reading exercise. How's everybody okay? It's death by examples today. In the next problem, I just switched the order of go. The inside is going to be 3 sine of 2x, and then the outside function is the e to the x. So here, inside, and we want to notice that our inside function has more inside it. because it's not just 3 sine of x, it's 3 sine of 2x. Constant multiples as inside functions, that's got to be trivial to us at this point in our mathematical careers. And our outside function is e to the stuff. This is where we have to grab our memory. We're taking this, the structure of this function is the derivative of e to some stuff. And so we access the memory and say the derivative of e to some stuff is e to that stuff. Then we apply chain rule times the derivative of that stuff. So h of x, h prime of x. The derivative of e to some stuff is e to that stuff times the derivative of that stuff. The derivative of 3 sine of 2x is 3 cosine of 2x times the derivative of 2x, which is 2. Because this one, once again, had more inside. Once again, this is a mess. It's one big term with multiple constants. Let's clean this up. So 3 times 2 is 6. I like my exponential stuff to go first, my exponential factors to go first. Got to keep an eye on this one. There's a hole in the box. The answer might start leaking out. Any questions? How's that okay? It only gets worse from here. All I do is start piling on more stuff that we have to put in. I just make the reading more complicated, and it escalates fast. How's everybody okay? Everybody's like, so I'm going to pretend that you're all looking at this like, oh, this is so easy. When is this going to get difficult? This is simple. This is trivial. Some of you are like, oh, no, opposite of that. Some of you are like, oh, exactly that. So that's why I just do a lot more problems. Now we just getting silly. Now it's just getting silly. We just have to get heavier weights to pick up and put down again. Here's what we want to do. We want to read. So we see a bunch of things going on here. I see a 5 cosine. I see an e to the 2x, and I also see a 3x. And we got to figure out how they're all being combined. So I see this, the 3x e to the 2x, I see those two multiplied together. So that's a product rule, but that product rule is sitting inside of the cosine. So that product rule is part of the inside. So in this problem, when we get to the derivative of the inside, we're going to need a product rule. But the whole picture is that we are doing a chain rule. It's the cosine of some stuff. It's just that in this case, the stuff is a product rule. And if you're like, oh, dude, that's really annoying, I'm like, oh, yeah, I know. It has to be annoying right now. So what we're seeing is that this inside is 3x e to the 2x. The inside has two instances of x in functions that are being multiplied together. So the inside is a product rule. The outside is just cosine. Outside is a cosine. The inside is going to need the product rule. So here we are, super stoked that we get to combine our rules together. Wow. Any questions about the read on what's going on in this function? When you think about what's happening to x, you say, first I would do an e to the 2x, then I would do a 3x, and I would multiply those things together. We just had to say two different things that happen to x and multiply them together. That says product rule. So the derivative of 5 cosine of something, I'm just going to write the 5. It's like the 5 just kind of tags along. The derivative of cosine of some stuff is, I didn't leave space for the negative. The derivative of cosine of stuff is negative sine of stuff. 5 is just a constant multiple. We just carry it along. The inside is 3x e to the 2x. And I need to multiply by the derivative of the inside. But the inside is a product rule. So now I'm going to write down the product rule. In the product rule, I'm going to call the first 3x. So the derivative of the first is 3. And then the second can be e to the 2x. And the derivative of the second is e to the 2x times 2. We want to get used to writing the derivative of the inside, if it's a constant like this, first. So now I got negative 5 sine of 3x e to the 2x times the derivative of 3x e to the 2x, which is going to be a product rule, which is going to make two terms. So I'm going to have 3e to the 2x plus 3x times 2e to the 2x. And then the 3 times 2 is going to be a 6. The product rule consists of two terms. So what else do I need? Right now, the sign, negative 5 sine is only being multiplied by the e to the 3e to the 2x. And then that last term is just sitting by itself. But I need to multiply this sum by the 5 sine. So I need parentheses. We need parentheses because the product rule consists of two terms. And I got to multiply the negative 5 sine of 3x e to 2x by both of those terms. How's everybody okay? Isn't it super fun? I don't know if super fun is the word I would use. Y'all are weird. It doesn't look great, but there's not a lot that we can do. So we'll work on the aesthetics at some point. But one of the things we notice that whenever we start doing product rule, quotient rule with an e to the x function, it just keeps showing up because it's its own derivative, right? And so we'd be able to factor out an e to 2x from all of this. We could also factor out an e. So we could have a constant, a polynomial, an exponential function, and then the trigonometric function. So if we wanted to write this nice, we might do something like take the negative, pull out another 3 and put a negative 15, get our constant. Our polynomial, if I take an e to the 2x out, is just going to be, I took a 3 out, 1 plus 2x. Factor out an e to the 2x from these two terms. And then let's see, a sign, what's left is a sign of 3x e to the 2x. So I got our constant, polynomial, exponential, trigonometric. If you're looking at this and saying, ew, gross, correct. Both of these are like, ew. There's not really a good way to write this. Note that the e to the 2x can come out of the polynomial part and leave behind a polynomial. I can't pull it out of the sign. It is not being multiplied by the stuff in here. This is how we ruined you with by writing the distributive property as a parentheses b plus c close parentheses. We wrecked parentheses forever when we did that. Sorry. Took away your ability to read things. Any questions? How's everybody okay? It only gets worse from here. So, I mean, take a minute and try to read what's going on in this problem. I made a very small change. Some of you are like, oh, this is very difficult to read when you make these tiny changes that have major impacts. That's one of the things that we have to train while we're learning math. And it's going to be more difficult for some of us to learn than others. Math is very difficult to read. And it's extra difficult to read for a lot of people. Without getting into all the details, what's the kind of big picture rule that we need to apply to this function? Product rule. The big picture that we want to apply to this function is the product rule. I would say that the first is 5x, and then the second is cosine of 3e to the 2x. I've got those two instances of x that are being multiplied together. So the big picture I see is a product rule. When we take the derivative of the second, what are we going to have to use? Well, derivative of cosine of 3e to the 2x, that's a composition of functions. So we're going to have to use the chain rule as part of our product rule. Yeah, don't be mad at me. I know I'm the one that wrote the function, but I didn't invent the product rule. This is just what the numbers are telling us they do, right? Don't blame me. He's all mad at me. I'm just kidding. I accept that. I am the villain in your mathematical story. So we want to read this as a product rule, where I say the first can be 5x, and then the second in the product rule will be cosine of 3e to the 2x. And for our second, we're going to have to use the chain rule, where our inside is 3e to the 2x, and our outside function is cosine of stuff. We're doing a product rule, and we're going to have to do the chain rule as part of the derivative of the second. Product rule with chain rule. The previous one was chain rule with product rule. Any questions? It only gets more fun from here, or depending on how you're interacting with this, worse from here. So P of X is a product rule inside of a chain rule. Q of X is a chain rule inside of a product rule. We just stack more stuff on. We put a chain rule inside of a product rule, inside of a quotient rule, inside of another chain rule, inside of a product rule. All right, that's going to be it for today. I have the sign-in sheet that you want to sign in on. And I have some stuff for you to pick up if you did not receive your chain rule at the beginning, or if you still have not received practice test 1. It's okay.
Do you have a copy of the worksheet we got yesterday?
I don't have a copy with me, but there is one on the
Canvas.
on campus.
Good thing.